All right. Today, I'd like for us to, guys, I'd like for us to get additional practice with solving differential equations. We did slope fields yesterday. Maybe we'll do a little bit of slope fields tomorrow, but we want to kind of get into that practice with solving equations. Sometimes not even with x and y variables. So if you guys can turn to page, I believe 15. Yeah, page 15. Okay, so let's read through the problem here. The rate at which baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams at time t days after it's first weighed, then db over dt is equal to what was given here. Let y equals b of t be the solution to the differential equation above with its initial condition b of 0 equals 20. Use separation of variables to find y equals b of t. The particular solution to the differential equation with this initial condition b of 0 equals 20. So db dt right now is at the derivative level. This tells us the rate at which the bird is gaining, the rate at which the bird is gaining its weight. But we're trying to get this up to b of t so that we can have an equation that will tell us the weight of the bird at any moment in time. Okay, so now I know we're used to seeing x's and y's, right? We said that when we separate variables, we want the x's on the right, we want the y's on the left. But you may also see problems where the variables may not feel as familiar. So if that's the case, just understand that if you see a strange variable, it's always going to be paired with time. And you're going to treat time like you would x. And whatever the other strange variable here, in this case b, you treat b as your y. Okay. So anytime you see strange variables with differential equation, it's always going to be paired with time. It's always time and another variable. Okay. So in this case, we want to group all the time, the t variables on the right and all the b variables on the left. But we just need to take our time with it. Okay. A lot of times we're not able to get full separation just on the first try. We kind of have to go through our process to get there. But first things first is I want to get the fractions lined up. Okay. So db over dt on the left. How can I write the right side as one clean fraction here? 100 minus b over 5. Okay. Just to get everything lined up, I like to see this just for my next step, because I know that I can line it up and get my fractions resolved once I cross multiply. Okay. And also, huh? Technically, we could drop the parentheses, but I do want to make sure that we understand the parentheses are there to help separate things for you. It's helpful. Okay. So what you don't want to do is you don't want to distribute the 1/5 through. If you distribute the 1/5 through, you kind of lose that that start position that the problem has begun for you. So normally when we solve integral problem, I always say expand everything out, right? Get rid of the parentheses. But here for differential equation, parentheses are there to help you. You don't want to lose the parentheses. Okay, so cross multiply here. Okay, 5 dB is equal to 100 minus b dt. Okay. The good thing here is we should have our dB and dt lined up nicely. Okay, so those should be sets. Those are locked in. We're not going to be moving those. But now the next question is, do we have full separation of variables? Not quite, not yet, right? So what has to be moved? Okay, but if I move the b, I have to move the what? Yeah, so the parentheses, they all kind of go together, right? So parentheses kind of also helps you in terms of if you have to move anything, the parentheses reminds you that everything inside the parentheses will move along with it. So we have to divide it, right? And if you divide something, it's going to end up in the denominator of the other side. Okay, so don't be afraid of putting something in the denominator, even though naturally it just feels like it's in the wrong spot. Okay, so we have to move the 100 minus b over to the left. Anything else that we could move? Move the 5, okay? And the 5 we can divide it over to the right side as well. Now, it's not wrong if you don't move the 5. It's just that typically we like to leave the left side as minimal as possible. So anything that you could move to the right side, you want to go ahead and move to the right side. It'll make things easier on the left side, and eventually it's going to have to come over to the right side anyway, so just might as well take that step. So I'm going to do two things at once. I'm going to divide the 5 over. I'm going to divide the 100 minus b over. So there's going to be two sets of denominators that's going to show up here. Okay. Everything looks okay for you guys? Okay. Full separation. B's on the left. All the T's and leftover gets moved over to the right side. Okay, so we should be ready for our next step, our taking our antiderivative. I'm going to rearrange this so that it feels more familiar in terms of the look of our problem. And just trying to make it visually a little bit more familiar, right? 1 over 100 minus b db, push the db out over to the outside the fraction, and I can pull the 1/5 out in front. I can have a 1 dt there as a reminder that I'm taking the antiderivative of 1 with respect to time. Okay, so left side here. Remember, treat each problem as independent of each other. Okay, what's involved here if I have to take the antiderivative here? Use substitution. Okay, the u value being, what could be our u value? Yeah, the entire denominator. Okay, and can you kind of foresee what rule this is going to eventually turn into? Yeah, 1 over u. Okay, but we do have to go through your substitution because this is going to produce something other than the 1, right? There's going to be a leftover coefficient that we have to keep track of because that negative b there. So du dp equals -1. There it is. It's a -1 that we got to keep track of here. Okay, everything I need is now can be substituted. Replace the 100 minus b with u. Replace the db with -1 du. I can pull the -1 out in front. Now have a nice clean rule that I can apply, right? Natural log of u, replace the u back in terms of b, and then the negative has to come along with it. Okay, so that's the left side. The right side should be a little bit easier. The 1/5, we'll just tag along to the antiderivative. What's the integral of 1 dt? Just t. Okay, and then we also need to include a plus c, right? Okay, so I'm going to reset here because this is the result of my left side. That's the result of my right side. I'll set them equal to each other. Okay, we've gotten everything out of the derivative level, but we still have more work to do, but we're making progress here. I'm going to put this at the top of the page here. Okay, look at what we have here. Okay, all the calculus is done. Now we're just trying to solve for b. But b is stuck inside this expression. What can we do? Okay. Yes, eventually, but there's something that's in the way of this e raised to e as a base. Yeah. This negative is in the way here. E to the natural log is a good property to get that canceled out, but e to the negative natural log is not quite that property. So what can I do to maybe get that negative to go away so I can have a nice clean, yeah. Okay, or multiply everything through by -1, right? So either way, if I distribute -1 through, I can get that negative to shift over to the right side, or you can think of it in terms of division, that's fine as well. But to me, multiplication feels a little bit more straightforward. Okay, the negative has to be accounted for on the right side, so we can balance things out. What does the right side become? Now, the C represents both what? Positive and negative values. So I would say just leave it as a plus C. Yes, we are distributing -1 through, but negative C is the same thing as plus C. It just feels a little bit cleaner if we just have everything as a plus C. Okay, good so far. All right, so now we can involve base E, right? The E and natural log are now paired up nicely. We can get that property to work for us. So the absolute value of 100 minus b drops down. Okay, the right side, we have a very specific way of cleaning this up, right? What's our process?
It's all an exponent.
It's all an exponent, and I can
Multiply it e times like that.
Times, good. So we have to change that operation, right? If we want to split it up, that plus is no longer going to be there. That plus is going to come down as multiplication. So it's going to come down as e to the -1/5 t times e to the c, right? So make sure that you understand that process. A lot of students want to bring that plus sign down, but we're using this property here, right? A to the m plus n is a to the m times a to the n. We're using this specific property here. Okay, and what do you know about e to the c? Just c is now being multiplied. So pull that c out in front, drop the absolute value. The c will take in the plus and minus. That's part of that process. Okay, so we're almost there, right? All we need to do is to solve for b, so it's just a matter of moving things around. Let's get that negative b over to the right side to make it positive. And then I want the c away from us. I'm going to subtract the c to the other side. Okay. Any questions here? So this is what we call our general solution.
Should we put e in the denominator so we don't have negative exponent?
You know what? It's okay to have negative exponent for these types of problems.
Okay.
So I would say just leave it up there. You won't, yeah, don't have to worry about negative exponents being an issue. Okay, are we good so far? I know it's a lot, but just want to make sure that every step along the way that you feel like you understand the steps leading up to it. Okay, so now we want to move to our particular solution. So particular solution, all it means is updating that C value. So what's available to us to move towards a particular solution? We have the order pair. Good, so we're going to plug in the order pair. Okay, now instead of x and y, we're dealing with t and b. So 0 is your t and 20 is your b. Okay, so we're going to insert them in. The whole purpose of this is so that we can get that c updated to be a numeric value. Okay, so 20 is equal to 100 minus. Now I know it's tempting to look at this initial condition and just say that, oh, 20 must be the C value. Normally that would be the case if it was just CE to the KT, but that 100 is kind of getting in the way, so we need to kind of take the time to enter it in. This initial condition is not going to quite be the C value, so we need to kind of discover that as we work through. Okay, so 20, I replaced 20 in for B, I replaced 0 in for T. What's e to the negative 1/5 times 0? 1, good. So negative 1/5 times 0 is 0. E to the 0 power is 1. That's going to wipe that out. I'm just left with 20 equals 100 minus C. Subtract 100 from both sides. I get negative 80 equals negative C, which means that my C is just 80. And if I have my C value, I can now take this and update it into my general solution, right? Replace that C with 80. Or you could write it as B of T to indicate that, you know, T is my dependent, T is my independent and B is my dependent, but either way is fine. So this is my particular solution. All right, questions with page 15. Okay, I'll leave this up here in case you need to look at it. Just to let you know, the key is also attached in the back, so if you're working ahead, you can definitely, on page 18 and 18B. Okay, but let's go to page 16. All right, anybody still needing this page? All right, page 16. Okay, first things first, what can we do with this y prime here? Right, so we're back to x's and y's. Okay, so back to x's and y's, so we can do dy dx. Okay, so anytime that I can move things around to get two fractions equal to each other, that's where I like to be, so I can just cross multiply and get my dy and dx's lined up. Okay. Diagonals. Take a step back and observe that your dy dx's are in their right spots. Those are good. You just have to look at the rest of the equation now to see if there's anything else that needs to be moved. Okay, is there anything out of place here? Just the y, right? That's the only thing. Everything else looks good. So we just divide that y over. It's going to end up in the denominator of the left side. Okay, take a look. Full separation. We're good. Everything in their right places. I'm going to maybe rearrange this. Pull that dy out to the right. Okay, left side, pretty straightforward. What rule can we apply here? Natural log, okay. But the right side, you have to do a little bit of what? U substitution, okay? What's the U value? X squared, okay? We'll go through that process there. So we took care of x squared, 2x shows up, ends up in the denominator. The x's cancel out, which is a good sign. But then there's a leftover coefficient of 1/2. So now we got to take care of the antiderivative, right? We got it all cleaned up. Now we have a rule that matches this. What's the integral of cosine? Positive, good, positive sign. I know it feels backwards, but with integral, we're going from the derivative to the function level. So cosine becomes sine. And then replace the u back in terms of x. So this is where we are. Left side is nice and easy, but the right side, we had to do a little bit of work to make sure that we didn't lose track of that leftover from the x squared. Okay, so I'm going to reset. I'll put this at the top of the page here. Okay, we're at the function level. But now we're going to work towards our general solution, which means getting y by itself. What can we do next? Involve base E. Separate those exponent terms. Notice the change in your operation. I'm sorry, this is just y, right? The natural log goes away on the left side. The c comes out in front, the absolute value gets dropped. Okay, so we call this the general solution here. All right, how do we move towards the particular solution from here? Order pair, good. Zero, insert 0 in for x, insert y, sorry, e in for y. All right, let's clean this up here. What's sine of 0? 0. Okay, e to the 0 is 1, so that goes away. I'm just left with c equals e. So now we're just going to take that c value that we found and insert it into our general equation, and now we have our particular solution. Okay, any questions here? Just updated the C with the number that we found. So this is fine. If you leave your answer in this form, that's fine. But I do want to talk about a different form that you may see, especially on the AP exam, when this is the answer, but they're cleaning it up in a form that that is different from this. So what they could do is they could do this. They could merge these two bases together. So technically there's a 1 hiding as an exponent, right? So e to the first power times e to the 1/2 sine x squared. So how can we merge this together to make it add them? Yeah. So it becomes e to the 1/2 sine x squared plus 1. Now you don't have to do this on a test, but I just want to point out that if this is your answer and the answer choice is here, it's good to know how to get from one form to another, right? So I just want to point that out. So this is, any of these three would be good enough for a particular solution. Okay, any questions here? Okay, page 17. I'd like for you guys to see how far you can get on your own with this. The key is attached, though, that if you want to kind of check your progress. But in a few minutes, I want to walk around first, see how you guys do, and then I'll go through each step with you, okay? Just want to point something out here that this will maybe come in handy a little bit later. Recall that there's a log property called power property, okay, which says that if an exponent is living in a natural log expression, that exponent can be free to move in front depending on if it helps your problem or helps you progress in your problem. So keep in mind that this can be done at any time. There's no calculus, there's no derivative process here. It's just a property that can be useful, especially if you're trying to clean up or if you're trying to do certain things. So, but yeah, first things first, right? Rewrite y prime, get your fraction set, and then cross multiply. All the fractions away. So this, we have to do substitution. You got it. Well, I left this on the left side because I was focusing on I mean, get you to flip it around this side.
Yeah.
Okay, let me share my starting steps here. Okay, replace the y prime with dy dx. And then I just move things around here. I just try to get this down to one fraction. So I made this negative x dy over dx equals negative y natural log of x to the fourth. I forced a 1 in the denominator so I can see how I can pair the diagonals. As I pair the diagonals, I want eventually my dy to be sitting on the left, and I want the dx to be sitting on the right. Okay, I can drop the negatives. And as I drop the negatives, I can see that hopefully you can see once you're here what is out of place, right? Looks like it's the y that's out of place and the x that's out of place. So we need to make them swap places, but as they swap places, they're going to end up in the denominator of their correct side. So dy over y equals natural log of x to the fourth over x dx. Okay. Any questions up to that point? Okay, so this is where I like to take advantage of that property. That 4, I'm going to make that 4 come down in front. I mean, you can let the entire numerator be the u value. It just feels a little bit cleaner if I can just get that out of the way. Okay, but it will end up being a u substitution problem because that right side is a little messier than any rule can handle. So there's my setup right there. 1 over y dy, we know that's an easy natural log there, but the right side, that natural log of x, with the 4 sitting in front, that 4 is out of the way, but we can let that u value be natural log of x, and that should handle nicely with that x that's sitting below. Okay, so what's the rule for natural log of x? Derivative is what? Yeah, u power over u, in this case is 1 over x, yeah. Go through your substitution. Cross multiply, x du equals dx. Replace dx with x du. That should handle nicely with this x. And it should clean up to be a nice power rule that we can use. All right, x's cancel out. I'm left with u du. Integral of u is just u squared over 2. You can do that, yes, you can do that. I just decided to get that 4 out of the way at the beginning, but if you let the u value be the entire natural log of x to the fourth, it'll still work out. Right, okay, that's fine. Okay, clean this up here. 4 over 2 becomes 2. Replace the u back in terms of x. And this is my antiderivative of the right side. 2 parentheses natural log of x squared. Now this is not something that the property can handle. We can't bring this 2 down because that 2 is affecting more than the x variable. Okay, so this is now my cleaned up stage of both sides. We start to solve for y, but at least we've gotten both sides up to the function level and the plus c showing up on the right side. Any questions up to this point here? Say it again. Yeah, 2u squared, and then eventually, though, I need to bring the natural log x back in. Okay. All right, so we're at the function level. We're one step away. How do we get that y by itself? And yeah, raise both sides, base e. Yep. So go through that process. We've been doing it quite a lot here. Okay, raise both sides, base e. The right side split up into two separate product terms. E to the c becomes c. Pull the c out in front. Drop the absolute value. Oh, why does that 2 not come down? Is that what you're asking, or?
No, I was asking like when you raise it base E, that natural log of x doesn't.
Because it's not, because it's being squared, and there's a 2 in front, so it's not as clean as we would like. However, just understand that on the AP exam as well, if you have your answer unsimplified, just leave it that way. Okay, don't mess with the unsimplified equation. You already have the answer. If you keep working at it, you may introduce a wrong step, and then that you just lose points there. So yeah, especially with differential equations, if you can get any sort of a version of the correct answer, just leave it, and then just step away and just understand that you can earn full credit without it being cleaned up. Okay, one more. Let's do page 18. All right, see how far you can get on your own with this and see how we do. So my suggestion is when you get down to the general solution, leave it as y squared. If you can just have that left side be y squared, I think that's good enough. Otherwise, you got to deal with the square root and wait until we do the square root. So just try to get to that y squared equals, and then that is good enough for general solution, at least when we're dealing with something that involves square roots. So before the square root shows up, get that y squared. I think that's a good place to be. And then we can move to the particular solution later. But first things first, right? Y prime gets rewritten. Get it down to be a nice clean fraction equals to a fraction. Cross multiply. And then decide if there's anything that needs to be done to get full separation. But I think for us, for this problem at least, once you cross multiply, you already have full separation, so that's nice. That means you can just move to the next step without having to do any rearranging. But you always want to double check, right? We can't assume that every time we cross multiply that we're going to be done, but in this case it is. Right? Y is on the left, x is on the right. Okay, left side, what rule can we use? Yeah, just power rule. Okay. Now the right side, there's a little bit of what? U substitution, but you can skip U substitution if you understand that the 3x will just produce a what? Okay, you're right, which is 1/3, right? Yeah, so 1/3, which with that 2, it'll be 2/3, but I'll show the full U substitution step if you need to see it. But if you're comfortable with a linear U value, you should just understand, you can just do a quick step, take the derivative, flip that fraction, and that is your leftover term. But if you want to see the full U substitution step, that's fine. Your U value is 3x, du over dx equals 3. There's a leftover coefficient of 1/3, but don't forget about the 2 that's already out here. So you want to involve both the 2 and 1/3, so 2/3. You know e to the u just becomes e to the u. Nothing changes there, it's just that that 3x is going to have a leftover impact. And then one final step to get it down to a general solution that's clean. Multiply everything through by 2 in order to get that denominator 2 to go away. And I like this to be, I think this is a good spot for general solution. I know you didn't quite get y by itself, but anything after this, you're dealing with square roots. And we can deal with the square roots later once we get that particular solution lined up. Okay, so I did my key a little differently. I plugged in the particular solution with this step, but I think it's a little bit cleaner to do it here at this stage. So I'm going to take my general solution, or my version of general solution, and insert the 5 and 0 in. If you do it my way on the key, it's fine. It's just that your C value will look a little different, but then in the end, our answers will all match. Okay, so part B, I'm now going to work in my ordered pair and try to solve for C. 0 in for X, 5 in for Y. You can use your calculator if you like. Now that I have my C value solved, I can work down to my Y variable. So take the square roots. But don't forget, there's always a what that's going to pop up with the square root of an equation, plus or minus. So those are two solutions, but we only want to pick the one that is appropriate for our problem. So which one do we choose? The positive or the negative square roots? Okay, why? Good. Look at your order pair. Whatever the sign of your Y value is the sign that you want to keep. Okay, good. We got through the problems I want to get through today. We will do more practice tomorrow and maybe do some more slope fields as well.
For this test, will we have to make these slope fields, or will we just have to interpret them?
If I make you make a slope field, it'll only be like 6 to 10 points.
Okay.
And then the others will be interpreting.
Doesn't really matter. Might or might not fail, so it doesn't really matter.
Why
It's
does
just
it
the
matter?
network.